Welcome back to session 2, Basics of Areas Related to Circles, chapter number 12. In this second basic session, we will understand the area of triangle when two sides are given and the angle included by them is given, followed by area of segment. We all know that area of triangle is half into base into height. So let's understand what I'm trying to say. So area of triangle, any triangle, when perpendicular is given, we write it as half into base into its height. So let's take an example of, we have a triangle, right, where this is A, B, C and this is perpendicular. So in this case, your area of triangle ABC, this will be half into base is BC, height is AB. Let's take a triangle in which sides are not perpendicular. I'm talking about any triangle. As I said earlier, I'll label this as again A, B, C. In this case, angle included by AB and BC is given. Let's take this as theta, included by side AB and AC. So in this case, when we don't have height, we are constructing a height. Let's say this is any side perpendicular drawn from B to AC, BD, which becomes the height. Now area of this triangle, area of triangle ABC, that will be half into base is AC and height is BD. I hope this is clear. Let's label this as 1. Right? Now what happens when BD is not given? We will try to get this BD. Using trigonometry, we know that sine theta equals to opposite side upon hypotenuse. You must have studied this in trigonometry. I repeat, sine theta is side opposite to the given angle upon hypotenuse. That means with respect to this triangle, when we see, so which side is opposite to the given angle theta? That is BD. And which is the hypotenuse? That is AB. That means sine theta can be written as opposite side is BD and hypotenuse is AB. So from here, if we cross multiply AB to sine theta, you will get the value of BD. That means BD equals to AB sine theta, where theta will be value any standard angle. It can be any angle ranging between 0 to 90, right? So after this, we got this value of BD. We will substitute it in the equation 1. So when you see this, now from 1 and 2, what we can say? From 1 and 2, we can say that area of triangle ABC equals to half AC. Already we have, instead of BD, we can write AB sine theta. That means in any triangle, when two sides, let's take this as PQR. When the two sides PQ and PR is given, right, and this theta is already given, so area of this triangle PQR will be, area of the triangle PQR will be half PQ into PR sine theta. Now same thing, try to understand. Same triangle I'm taking, what was given to us, ABCD. That means I'm taking this triangle again, and this was our triangle, right? This was A B C. What I'm trying to explain through this one, if suppose these two sides are the radii, that means if the points B and C are on the circle and A is the center, so see what happens in this case. A circle is passing through BC where A is the center, where A is the center, where this theta was known, and AB equals to AC is equals to R. So now friends, this area of triangle ABC will become what? Equals to half into AB into AC sine theta. That means this will become half AB into AC is R square sine theta, half R square sine theta. That means this is the area of the triangle formed by two radius when angle included by them means central angle is given at the center. I hope this is clear. You have understood the area of triangle ABC. Now moving further, let's talk about this area of this part. What we call this part as the shaded part. This shaded part is nothing but we call it as segment. In the last video, session number 1, already I have explained you the area of sector, right? Here we need to find the area of segment. So general formula for area of segment is area of segment, or let's name this as BDC, segment BDC. General formula is equals to area of sector minus area of triangle. I repeat, this is just the general formula. We are trying to derive the direct formula for area of segment. So what area of sector we have, friends, from the previous video which you have understood, that was theta upon 360 into pi r square. And what formula we have derived for area of triangle? Half r square sine theta, right? So this will become, you may take half r square common. What is the remaining? Pi theta upon 180 minus sine theta. So friends, this is the final formula for area of segment which we can use to get the area of segment, provided that angle, central angle must be given, and you should know the sine ratio of the given angle. You should know the sine ratio of the given angle. Just for your information, I am writing sine ratios of different angles. So friends, we have a sine 30 equals to half, we have a sine 45 equals to 1 upon root 2, then we have sine 60 equals to root 3 upon 2, and sine 90 equals to 1. Further, sine 120 equals to root 3 upon 2, sine 150 equals to half. Right? So let me quickly revise what we have done in this video. I have tried to explain you area of triangle. General formula is half into base into height, that we all know and we are studying from 6th and 7th standard. So here we are trying to get the area of triangle when base and height are not given, two sides are given, and angle included by them is given. So friends, in this case what we are doing, we are constructing a perpendicular passing from vertex B to its opposite side. You may construct from anywhere, you may construct from C to AB, that's your choice, right? So from here, I repeat, we are constructing perpendicular from B to its opposite side AC. So therefore we can get area of triangle ABC is what? Half into AC into BD, where AC is the base and BD is the perpendicular height, or you may say altitude. So from trigonometry what we know, right, sine theta is side opposite to given angle upon hypotenuse. So when we see this triangle ABD, which side is opposite to the given angle theta? That is BD. And which side is the hypotenuse? Exactly the side opposite to the 90 degree, that is AB. So therefore sine theta is what, friends? BD upon AB. Therefore from here, if we cross multiply AB with sine theta, we get BD equals to AB sine theta. So when we see this expression 1 and 2, when we combine them, we get area of triangle ABC equals to half into AC into AB sine theta. That means area of the triangle when two sides are given and angle included by them is given can be written as the product of these two sides along with sine ratio of the given angle. That means area of triangle is half into first side into second side into sine ratio, right? So just to make you understand, instead of ABC I took another triangle PQR, where PQ and PR are known and this theta is given. So the area of triangle will be equals to half into PQ into PR sine theta. Let's take this same triangle ABC. Now here in this triangle ABC, I'm just trying to make you understand what is happening here. AB and AC are the radii, where B and C lies on the circle and A can be a center of the circle. So what happens, a circle is going and we are getting ABDC as a sector. So in this case, let's see what area of triangle we are getting, friends. So that is half into AB into AC sine theta, but we know from the figure AB and AC are what? AB and AC are nothing but both are being radius. Therefore this will become R into R sine theta. That means half R square sine theta, right? So area of this triangle ABC in this case will be what? That is half R square sine theta. So let's coming back to our objective that we want to derive the formula for this part. This part is known as segment. In the last video you have understood area of sector. The same thing we will be using here. So area of segment this part is equals to area of triangle is being subtracted from the area of sector. So that means area of segment equals to area of sector minus area of triangle. We know what is area of sector, theta upon 360 pi r square, minus what formula we have derived for area of triangle from here, half r square sine theta. So what can be taken as common? We can take r square common, right? So when you see this theta upon 360 can be expressed as half into 1 upon 180. That means we can take half r square common, and what is the remaining here? pi theta upon 180 minus sine theta. I hope you have understood this area of segment. Just for your reference, I have mentioned some of the sine ratios of different angles. Sine 30 equals to 1 upon 2, sine 45 is 1 upon root 2, sine 60 is root 3 upon 2, and sine 90 is 1, sine 120 is root 3 by 2, sine 150 is half. If you want to make a note, you may write it as sine 135 as again 1 upon root 2. These are some of the sine ratios. Hope you have understood area of triangle when two sides, an angle included by them is given, and you have understood the very important formula, area of segment. You may stop this video and you can make a note of this full material. Thank you so much. Hope you have understood and you will like this video and you will share it with your friends. Thank you everyone.